All right, Jonathan, thank you for having me. Nice to meet everybody. Um, Hello all. My name is Jordan Fraser, and here to give a quick presentation, hopefully less than 15 minutes or so, on our project Kaskada, which is a data processor built on Rust and Apache Arrow. I threw these slides together pretty recently, so apologies if it sounds like I'm reading off notes, because I mostly am. So who's this talk for? First thing, people relatively familiar with Rust, which it sounds like most people are. You may have heard of Apache Arrow before or not. It doesn't matter. We'll do a little bit of background on there. If you want to see how Apache Arrow is leveraged in Rust, or you're just interested in data processing. So first thing I'll do is I'll give a little bit of background on Kaskada and Arrow, some of the reasons why we chose Rust and Arrow, and then a few specific challenges and lessons learned while writing Rust with Arrow. So for a little background, Kaskada is an open source event processing engine, somewhat similar to Apache Flink or Apache Spark. Kaskada was started with the idea that as the world shifts to real-time data and people want to make predictions in real time, you need a compute engine specifically tailored to handling timestamped event-based data. So Kaskada can be used as a general purpose data processor, but it excels when working with temporal data. So this leads to it working well for data scientists who want to generate data at a specific time, then use that data at some time in the future to make predictions. For example, I want to know whether events happening right now indicate whether one of my employees will churn next month, or a common example is whether an unusual credit card transaction might indicate credit card fraud. So this process involves data engineers, data scientists, building and training models on historical data, which when put into production can then be fed real-time data to make real-time predictions. So here's a basic diagram of how Kaskada fits into that machine learning lifecycle. Events flow into our feature engine, and results are produced to either train models or to send to feature stores, which where values are then served in production to make predictions. And so this simple Fenl example, where Fenl is our feature engineering language, is just a step in a sequence of queries that allows a data scientist to train a model on how often they should offer promotions to users playing a game, depending on how often and recently they either won or lost that game. So this query is defining a feature, which is just a value that we're interested in, the time to make the prediction, and then shifting that prediction forward in time to an example time, at which point the example will be used to determine whether to offer that promotion or not. And this temporal shift here is one of our key features that allows data scientists to quickly train models for production. And so we actually wrote the initial implementation of Kaskada and Fenl in Scala, which used row-based computation. And we unfortunately found that to be pretty inefficient. One of the main reasons being that for every row we process, it had to do these extra conditionals and match on the type of the input values, and extrapolating that to gigabytes of rows, it was adding up to a large performance loss. So, to illustrate this a little bit, imagine you're just reading rows of events here, and you're interested in summing up the total cost of sales per customer. So in Scala, using row-based compute, we first had to extract that desired field from the row, then run a conditional that had to match on the type of the input event for every single row. You see in our aggregate method here, we're doing, as I said, we're extracting a field, and then we have to do that match. So again, for millions of rows, this was a severe performance hit for us. So a few goals we had in mind when finding a solution. Performance obviously was the foremost, but theoretically, as we scale, we need a high degree of concurrency, and type safety is always nice to have. So what do we find? Apache Arrow is an extremely fast columnar in-memory based data framework. So one of the key features we were obviously interested in was the columnar memory format, which allowed us to skip that conditional for each row. And I'll show an example in a few slides. But Parquet, Spark, Pandas, Arrow, and many more popular projects all use or leverage Arrow. And given its language agnostic design, it's also a great choice for compatibility between data projects. So why do we choose Rust? Rust is known to be highly performant. It's got great type safety and concurrency. It's also got great control over those low-level details like memory storage, so we were able to spend the time to optimize our header instructions. For many of us, it was our first time using Rust, so the compiler diagnostics were super helpful when learning how to be friends with the borrow checker. I personally would still consider myself to be acquaintances with it at best, but I'm working on it. And one of the biggest factors, though, is that there's a native implementation of Arrow in Rust. So the Rust implementation is not only more performant than Java's, but it's also easier to work with because the Java implementation requires a lot of manual work to manage those memories for its arrays. And we just didn't want to work in C++, honestly. So, yeah. All right, so getting started with Arrow and Rust. Central to Apache Arrow and Rust is the record batch, which is this encompassing struct that wraps your data schema and columns. And so where Arrow is a columnar-based memory format, I'm sure people are familiar with Parquet. It's a columnar-based disk format, and subsequently is one of our main storage and input types. In this abbreviated example, we're using Arrow's built-in types to work with Parquet and convert batches of rows into record batches. And here we've created a stream of record batches, and we're able to use async Rust to await a future from that stream. So it's all relatively simple looking once you figured out the type system, but initially we had a lot of trouble figuring out how this actually all worked. So one of the more complex problems we had to learn about were these dynamic stream types and how to use them in async code. So this stream.box call at the bottom here is an async Rust function that wraps the stream in this, what I think, wildly complex box string type. And so working from the inside out, the first computation we see is the din stream, the dynamic stream. And Rust can't just create this din stream because it's an arbitrary instance of the stream trait. And anything you pass by ownership must have a statically known size so the compiler can determine how much to remove from the stack or how much to move on the copy. And so one solution for that is boxing, which allocates space in the heap for data and leaves a statically sized pointer to that memory location. And when we get to the pin, pinning ensures that data has a stable location in memory, which is necessary to do in certain cases, as by default Rust allows all types to move in memory, and futures specifically require pinning, as calling it's a self-referential data type. So combining these techniques, we box the dynamic stream, we place it on the heap, we've pinned the location, the pointer to that memory location, and giving us an async string we can safely pass around to produce our record batches. And unfortunately, I did not come up with this extremely clever title. There's a great and terrifying walkthrough of pinning in Rust, titled Pin and Suffering. I recommend you read if you, actually I don't, but yeah. Okay, so enumeration of types. Let's see, speaking of complications for types, another challenge we found was how to support and map all the Rust native types to arrow types. And so we found that in some places you do have to do this enumeration and map each type in order to generate the appropriate evaluators, but there's some tricks we used to reduce the amount of code and generated code we had. So one of the areas in particular we'll focus on for this problem is in our evaluators, which are our aggregation instructions, things like counting, min-max, or summation. And each of these evaluators also needs to be able to support all of our appropriate types, such as 516, 932, Boolean strings, etc. So the first thing we obviously did not want to do was handwrite evaluators for each type, as that results in a lot of duplicate code with only difference being which arrow type we downcast to. So the first, obviously, we did was add a generic type T, and assuming that T can be aggregated how we want, for example, support summation, T plus T, then at least we've now consolidated our primitive types into a single sum evaluator. But unfortunately, we would have had to duplicate this implementation for each aggregation we support. So, what can we do better? What we came up with is using a shared trait for each aggregation type that allows it to define how the values are operated on, stored, and produced. So this ag function trait defines common functions that allow each aggregation to define how they will behave given an input. And we can see on the right now that we have the sum behavior mostly implemented nicely as an aggregation function. So how do we come back and use that in our evaluators? So here we see the final pattern for the primitive evaluator, which now supports all of our arrow primitive types and aggregations that implements our ag function traits. There's another layer deeper than this that we have to ensure that the types in ag function also support numeric properties like addition, min-max, and separating add, but the general principle is the same. We were able to use Rust traits and generic types to significantly reduce the amount of code we need to write to support our aggregations and all of their supported arrow types. So, of course, we then still had to decide what type to instantiate the evaluators with. For each aggregation, we needed to generate a typed evaluator. And if we had to write each of these instantiations out, we'd have that n-by-n matrix of different combinations to do. But luckily, we have Rust macros to generate this code for us. The example here, we can see that the create type evaluator on the left macro is generating all variations of arrow types for our primitive evaluator and our aggregation function trait, which allows us to simply call our macro with a specific data type. In the end, though, so there's no getting around some enumeration of types in order to map to arrow, but leveraging Rust's built-in capabilities allowed us to do significantly less work. So on to some of the interesting performance stuff that we did with arrow now is columnar data processing. So earlier I mentioned that row-based compute was one of the main reasons we moved off of Scala. By moving to arrow and constructing evaluators specific to each type, we were able to utilize columnar-based compute much more efficiently, where the general principle is the less you do in the inner loop, the better. You get better cache efficiency, less reflection indirects. Yeah. Fairly simple concepts, do less often, but sometimes difficult to implement in practice. So mostly pseudocode on the right, but the general structure highlights the advantages of our columnar-based compute. In the top example here, we have to iterate over each row in the batch, and for each of those loops, we need to extract the field, match on the type, and do some work. But when we're doing arrow, we're able to downcast the entire input column once to our known type, then map over those values without any additional conditionals within the loop. And this is one of the main reasons arrow and columnar compute are so well suited for data processing. And lastly, another small trick we've done is inlining instructions. For example, the update accum method here is run per row. By adding the inline attribute to method, we're strongly suggesting to the compiler to inline that function. And entry to and exit from these hotter functions generally accounts for non-trivial amounts of execution time. So this was an easy trick for us to get some performance wins, but not the only reason that we did it. In our aggregation function here, we have two cases that want largely the same logic, aside from affecting this is valid bit. So first, we're factoring the function out, let us avoid duplicating that code. But then adding the inline attribute tells the compiler to put that chunk of code back inline our aggregate function. However, at that time, the compiler can optimize away the conditional because it knows the Boolean is always true in this latter case. And, obviously there's more differences in our Rust implementation than Scala than just these, but for some napkin math performance numbers, our current Rust implementation evaluates, in the millions of rows per second, whereas with row-based Scala, we were seeing tens of thousands maybe. So we saw a huge performance increase switching to Rust and Arrow. So I can't conclude without mentioning some of the more downsides, though. We do have to do this type mapping. Because we're parsing expressions for custom-defined types, we have to define how our input types map to arrow types, with often results in these large conditionals. Fortunately, most of these are right ones forget about once they're defined, so it's not an overly big inconvenience to manage. But overall, we found that Rust with Arrow has been a great combination for creating a fast event processor, shown highly performant execution, Arrow's got a relatively active community, and it's got a number of built-in functions for us to use out of the box. But as shown, we did have to work through some challenges regarding the type system and learning some of the more efficient Arrow and Rust use cases. But yeah, and as we introduce Kaskada to the open source community, we hope to make it easier for everyone to work with Arrow and subsequently us at Kaskada. We're going to plan on contribute crates for connecting streaming services like Apache, Kafka, and Pulsar to Arrow. And yeah, thank you all for your time. I'm happy to attempt to answer any questions you have, and available on GitHub or Slack. Thank you.
All right, very nice. Do we have any questions from the audience? One thing I was wondering is how involved are you with the actual Arrow project? Because it sounds like you're contributing to Arrow itself, if I'm not mistaken.
I'd like to definitely get more involved with that. At the moment, some of the stuff we've contributed is more lower level on their functions, or as they call them, kernels, which are the self-contained compute kernels that do summation or subtraction, that kind of stuff. So we've done a little bit there, but we'd like to work more on the integration with Arrow and other popular services next.
Okay. So do you think it would be very easy to, like for someone who's a bit newer to get started with contributing to Arrow and helping out there, or contributing to Kaskada at all? Like, how do you see that going for someone who's kind of like a beginner who's interested but maybe isn't like onboarded with Arrow and all this other stuff?
We're definitely happy to help anybody get started. We're going to start holding office hours and Q&A sessions. But new people we would love to have, because one of our goals in this next cycle is to make Kaskada more open sourcey. We want to move towards like a library format so they can easily pull Kaskada into their existing projects and just use it. So a big part of that is going to be refactoring and simplifying our code base, which new Rust people will definitely tell us where we need to simplify at. So
okay. So would you say that most of the performance benefits using the Rust implementation came from just switching from row processing to the more columnar oriented processing?
I think absolutely yes. The columnar-based compute is just obviously highly more efficient, but some of the other changes we did were in Scala, we used the Akka messaging framework, which we honestly had a lot of trouble with. It was a lot harder to work with that messaging framework than just using async and Rust.
But Scala also has futures, which are similar to async and Rust as well, right? Like they have futures and promises. So
yes. When we used Akka in Scala, we had started building bigger than we should have, in that we were building our project out for a distributed system at that time, when we probably could have just been using more simple features.
Right. Because one of my lingering, I guess, doubts in my mind is that I wonder if it wouldn't be possible to push the Scala implementation a bit closer performance-wise to the Rust one, just by processing, doing the more column-oriented processing, and just trying to take advantage of some of the optimizations in terms of just algorithms and data structures that you're doing with Rust. But I guess I'm not deeply familiar with this space, so.
Yeah, no, absolutely, I agree with you. I think that our initial implementation was very poorly optimized, and it might have been worth a shot working in Scala with the columnar-based compute. But one of the biggest benefits of using Rust was that Arrow had that native implementation in there. So it was just a lot easier to work directly in Arrow or in Rust.
Yeah, and if I interject for a minute, the other problem is that Scala's on the JVM, which means the implementation for Arrow goes through byte arrays, which means I have none of the benefits of the types. And then if you start going through the FFI for Scala, if you want to go down that path, then unfortunately for the JVM FFI, you have to copy an entry and exit, which means most of the, I don't know how much, it's a considerable cost, which might have not given us as much of a benefit if we did Columnar in Scala compared to doing Columnar outside of a JVM.
Mm-hmm. Okay. Yeah, I have some experience using or like implementing a Spark connector using Scala, but I've never done any of this kind of thing in Rust. So yeah, it's very interesting to see this perspective.
There's some other things that we haven't yet explored, but we want to. The fact that with the Arrow Rust implementation being more of a systems programming language, you have better access to actually hook up into GPUs. And columnar data and operations on them work really well with GPUs to get all the single instruction, multiple data, SIMD and NUMA sort of optimizations. We haven't done it yet, but we're kind of, time allows, it's one of the next big things to help with performance.
Okay, that's pretty interesting. And do we have any questions from the audience at all?
All right. Thanks for listening, y'all.
All right. Thank you for coming out here and talking. So with that, I'm going to just move on to the, I guess, bigger announcements before we get into our free discussion. So first thing I want to talk about is the result of the poll. So for those of you who are joining us today, you almost certainly have RSVP'd for the event and saw the question. So the question was whether or not we should run our future meetups using Google Meet or Discord. And we got a pretty high number of responses for the number of RSVPs that we got. And the final totals were 17 in favor of Google Meet and 8 in favor of Discord. So basically, it seems the majority of people prefer Google Meet. Maybe they're just not that interested in trying Discord, or they're a bit afraid of trying Discord. I'm not really sure, but I did say that I probably wasn't going to switch things unless we had like a super majority of maybe like 60 to 70% of people preferring Discord. And I know that the sample size is relatively small, but I did want to make sure that we asked people who, you know, at least intended to come to the meetups, people who actually RSVP for the events, what their thoughts are, rather than just, you know, anybody who, you know, might not really be a stakeholder here. So yeah, going forward, it looks like we're just going to be continuing using Google Meet. So that's pretty much it for that. I don't know if anyone has any questions about that or any concerns or comments. You can also vent your frustrations or disappointments if you want a Discord.
I
No.
think the recording would have been more challenging with Discord in terms of, you know, being able to record the meetups and stuff. And
yeah, that's true. But I think there would have been solutions we could have come up with to make that possible.
right, but I feel like the what's the word? The solutions, are, in my opinion at least, are not as mature as those for Google, because Google kind of, you know, they have more riding on how it works.
Okay, fair enough. Yeah. That wasn't really, I think, a major factor for most people who voted, though. I think.
I don't think that's a big
that's
factor.
more about for us. That's like a problem
Right.
that we have to deal with as organizers. We have to figure out what to do there. So
right.
yeah, I mean, if anyone's concerned about that sort of thing, it's mostly just us.
Right.
Also, welcome, Evgeny. You joined just after the presentation and also after I announced the results of our poll, which is that Google Meet has won over Discord in a vote of 17 to 8. So, yeah.
I see. Hello, everyone.
We're doing good, I guess. So the next thing I wanted to talk about was actually our next meetup. So we have a couple of people who are interested in talking next month, and I'm still sorting out the details there. However, it sounds like both of them want to do their talks from May 10th to 12th or somewhere in that time frame. So do be aware that it may be earlier than usual next month. Keep an eye on the schedule, on the calendar. We'll probably leave a note on Discord as well if you're on the Discord server. And it seems like it's because there's an event happening at the Vancouver Convention Center. So that's why a lot of speakers are coming out here to Vancouver at that time, and they want to actually do a talk on those days and get involved in our community. And I believe, if I'm not mistaken, and I actually don't remember, but actually, no, it's not this open infra thing. I don't know what the event is from the 10th to 12th. There's definitely something happening at the convention center, but there's also the Open Infra Summit coming up. I posted about this on Discord. It's also in the description for next month's meetup. But I'm also going to post the details here in the chat. It might be a lot, actually. Oh yeah, it wasn't even enough to put in here. Never mind. The important part is that there's an event happening at the convention center from 13th to 15th of June. And there's a discount code, I believe, if you're interested in getting tickets for that. I'll just find that here. Yeah, if you're interested in going to the event, discount is YVR Meetup. Oh, yeah, the Open Source Summit is on the 10th of May. Thank you. Yeah, that's what it was. Yeah, so this code decreases the ticket price to $4.99 USD, which is still fairly expensive, but you know, it's at least a discount. Registration is open until May, and yeah, I guess I can also throw in a link to the event as well here. But again, all the details are on the meetup event page for next month. So if you're interested in seeing this information again, don't worry. You don't have to write it all down right now. It's all up on the meetup event. And yeah, I think that's about it. I don't really have anything else to say today. So yeah, keep an eye on the calendar because next month's meetup may be a bit sooner than you expect. But yeah, still need to work out some details and figure out who's actually presenting and get everything scheduled accordingly. So with that, I think we can just move into our regular free discussion. So if anyone has any topics they want to talk about or anything interesting news-wise with Rust that they think we should discuss, then now would be the time. If you want to share any links, you can also share those in the chat as well. And yeah. Anyone have anything they want to talk about? Anything interesting? I know there's something interesting that did happen recently with the Rust Foundation, because I know they recently announced their plans to, I think it was create a new trademark policy, if I'm not mistaken. And I saw there was quite a bit of buzz around that. I'm not super caught up on all that, but I know that Graydon, the original creator of Rust, even stepped in and made a comment on it, saying he didn't really like the wording of the new policy, and now it looks like they're kind of backpedaling, and seems like they're maybe revising it. So yeah, kind of interesting.
What were some implications of that new policy?
Some of the implications of the new policy were stuff like you can't use the words Rust or cargo in domain names, I believe, or like you have to get permission for that. Yeah, there was a bunch of stuff that seemed very from the discussion I read, it's more like they want to make sure that people understand that they're not going to actually enforce all these things. They're not actually going to use these powers necessarily, but they still have the community's best interest in mind and all. But yeah, a lot of the backlash came from the fact that the Rust Foundation as it is right now is a certain set of people, and eventually people will leave and other people will replace them, and we don't really know what they'll do with that, right? They might actually start abusing what powers they have been given. So there's definitely been a lot of discussion. They opened up a feedback form, I believe, and yeah, it seems like a kind of messy situation, but it looks like they're sort of they sort of got it under control now. I guess we'll see what happens when they revise the trademark policy. Yeah, I think there are some links to it. Here's a link to the statement saying that they're going to revise it. So there's that. Rustmagazine.org. What's this?
Yeah, I posted that. I came across it about a week ago, and they have interviews. They have how to do something in a week in Rust. One of them has a mini storage engine in Rust in a week. So they walk you through how to write a toy little storage engine in pure Rust. They had some interesting titles, but as I said, I haven't had the time to sit down and read about them. And in case other people didn't know about it, it might be a fun read.
I've never heard of this one before. That's interesting.
Oh, yeah, we probably should release that last article on the SQL optimizer using egg. We actually use egg in our system as well to optimize our VFG.
Egg.
There's a fun one called Using Category Theory to Parse Command Line Options. So if you really want to try your teeth on some theory and code at the same time, that looks like a good title.
Oh, that sounds interesting. I'm not sure I feel that Rust is the best language to be playing with category theory, because I usually associate that with like Haskell or like Agda, or a language that is a little bit more like purely functional. But okay, and most people would just use clap, I think, for command line argument parsing. But
yeah, but as I said, some of the titles a lot of the titles piqued my interest, which is not that common for a magazine site. So
that's true.
I want to go read it.
Yeah, these are actually really interesting. I mean, it's sort of like a fun little exercise to see like what you can do with Rust's type system. So it's always neat to see what people come up with, for sure. Egg. Is egg the egraphs good library? Oh my. Yeah. I've heard about this before. This is not the first time I've heard about this. I think
apparently there's a new somebody, a group of people wrote a paper where they took data log and egg and unified it together. So now you can write the same kind of rewrites in a data log with egg sort of capabilities, which is fascinating. But again, I haven't read it yet.
Oh, wow. Yeah, I don't really know much about egraphs, to be honest. I saw some people suggesting Idris use eggs or egraphs or something at some point in the Idris Discord, I believe. But yeah, I didn't really understand egraphs, I'll be honest. Okay, this is neat.
I'm not sure if you guys looked at the talks from the Rust Nation UK, but there was one of them on building UIs that I found was just it's not in my opinion as great as something one code base like Flutter where you have one code base and several UIs, but it will still allow you to write the core of your UI in Rust, and then you just put a shell, as they call it, on top of it in whatever platform specific language to do the actual look of the UI, but the logic of the UI could be built out in Rust. That was a general summary of my interpretation of what they said. But just it sounded cool to me because I'm right now in the process of trying to pick approach to develop a UI for a web service that I'm building. The current approach is just use eGUI to build something quick so we can get feedback, and then we'll decide on something more permanent. But I don't know if anybody has any UIs that they would recommend, preferably that can be written in Rust. Not super interested in writing a lot of JavaScript. Fair enough.
I haven't done much like GUI stuff with Rust other than I guess U, if that counts.
Yeah, I have looked at you, and it is probably one of the front runners. But I've also heard some less appealing things about you. It's not necessarily the fastest, which is not a big concern for me. But some people have said that it's not the easiest to use either. I guess I still have a little bit of time before I have to make a final decision on that. So I guess I'll kick that bucket down the road a little while longer, because eGUI is definitely very different from what I'm accustomed to in terms of building UIs, because I was definitely more familiar with the browser kind of thing where you have your DOM and you update the DOM as you want your UI to change, instead of, and you have callbacks to have functions that do things when you click on a button or whatever. So that's what I was accustomed to. And this immediate thing where you say, if button is clicked, do this, and that both draws the button and implements the behavior at the same time, is really different, and it's kind of cool. It's just it's not the prettiest because it makes layout a little bit difficult because you're immediately drawing everything as you defining it, but it does make it really easy to mock up a UI.
Okay. I don't know. That sounds like it might be a more like imperative approach versus use, I guess, sort of declarative framework.
The
I mean, it's
use is
basically like
immediate.
React.
Right. So you have the reactive thing like what you and those things do.
Yeah,
It has a state, right?
It's React, but you have to contend with the borrow checker. At least that's my experience with it. This is like, oh, you want to pass that callback? Sorry, you gotta clone it.
Yeah. Actually, my recent experience with TypeScript has left me wondering if maybe I'm doing it wrong, because it it doesn't catch most things for me. I feel like I'm always double checking my work kind of thing. Whereas with Rust, the compiler, I know there's a hard line that when I click compile, either I've done it right or I haven't done it right. But with TypeScript, it lets all these any's just slide in all over the place. And if I forget to put a type, it just becomes an any. And I'm like, that's not what I want. I wanted some guarantees, please.
Yeah, I don't know. My experience, like, I've worked with some students running workshops at UBC, and I've seen some pretty weird and strange errors coming from the TypeScript compiler, and some of them are pretty hard to solve or figure out without like commenting stuff out and like I guess poking at it a bit before you finally get an error message that tells you exactly what's going wrong, which I find happens less often with Rust. It definitely feels like, yeah, there's the way that they've done the type system in TypeScript feels like they wanted something more dynamic, something more flexible, but ultimately sometimes can really throw you off at times. I don't know. So I guess I'm saying I've had similar experiences sort of vicariously through trying to help students with really strange compiler errors, but
Well, I guess to be fair, it was a JavaScript project that I was trying to turn into a TypeScript project because I was having type errors. So it's not like I was starting with a clean plate. It was kind of dirty water to start off. It seems like Google either fixed the bug or created a bug in V8 because I have a script that's been running for about 2 years now. And then in January, it started giving me a different total for one of my calculations. So I thought it was the data, I thought the data definitely changed what I was doing the calculation on. Check the data, and the data hasn't changed. And the data, if I add it up by hand, gives me the old total. So I don't know if it was some bug that I was depending on in my code accidentally that was causing me to get the different answer before, or if Google changed something that broke it. But to try to debug it, I just need to fix up all the types because it was written in JavaScript, and that was, that was the best I could do at the time, but it's not sustainable.
yeah, fair enough. Okay, I see a link here from Edgar. Leptos. Build fast web applications with Rust. I don't think I've heard of this one. What's this?
Yeah,
It's
you
go
can
ahead,
build
Edgar.
web clients with it, but it has more of a different kind of state management. Kind of like Solid JS does, instead of following the state management pattern that like React did. So it has signals and stuff like that.
Okay, interesting.
So it has fine granular updates pretty much. So it's a little bit faster than what you would get with you.
Yeah, it looks similar, at least with like the view macro. It's kind of like the HTML macro, except it looks like you're passing in a context or I guess scope.
Yeah.
Okay.
Exactly. Yeah, so you still have how you declare, right, the HTML, but the way that the updates occur, it is a lot different.
Yeah, that's
Right. I did look at that one. It was definitely one of those I looked at a lot more closely because I like the idea of the fact that you don't need to maintain a shadow DOM and compare them every time.
Yeah,
The targeted updates, I thought that was really cool.
exactly.
But I was a bit concerned that it is a bit young still, so that, it might still be a lot of churn, and I'm not really looking to build on a lot of churn right now. But thanks a lot for sharing that one. That one is definitely one that I want to keep an eye on.
Yeah.
okay. Yeah, this looks interesting. Yeah, that definitely seems like it's less mature, but could be really, really good later. I might have to check this one out too. I don't want to. I don't know. I don't want to just get into an exploration phase right now, though, with my project. I think I'm just gonna stick to what I know and what I'm currently using, and roll with that for now. And maybe later on, I'll swap stuff out. I don't know. It's like, I don't know. I've already spent the time and effort learning Warp and U, and now I'm just like, I want to just get stuff done and then worry about what's, I guess, optimal later for my use case. All right. Does anyone else have anything else they want to talk about? Anything interesting to chat about today, or are we all good?
Yeah, I'm good for tonight. I'm guessing we would also send out an email, right? If we change the date for the next one.
Yeah, I'll try and send out a notification. I'll send it out on Discord, and I'll also try to send out some kind of notification via email through Meetup, probably. We'll see how that goes. Yeah, I'll probably just send it out to the entire Meetup group. Which, yeah, by the way, we've hit over 1,000 members now, which is kind of neat. Cool milestone, I guess. Don't know if that matters to anyone or if anyone thinks that's really cool, but yeah.
It definitely means that our turnout is decreasing as a percentage of our total. But yeah, it's still cool.
Yeah, I mean, like, I feel like the number of people who actually show up to the meetup still like wildly varies. But I mean, hey, at least we're not having 2-person meetups anymore. So I mean, there's that.
Yeah.
We're more consistently having at least, like, I don't know, like 7 or 8 people show up at least. And then the occasional, like, I don't know, 27 to 30. It's pretty good. Still have no idea like what causes more people to show up on certain days and what causes them to not show up on other days. But I don't know. It's a mystery.
Yep.
Anyway, thank you all for coming to today's meetup. And yeah, I'll be forwarding along the recording so everyone can see it in the thank you email. And yeah, if you have any questions or concerns, if you're interested in doing a talk or helping run the meetups, let me know or let Chester know, and we'll see what we can do.
All right. Thanks, Sean.
All right.
Yeah, thanks a lot, Jordan. It was really interesting.
Yeah.
I wasn't familiar with those things before. Thanks.
Thanks, Chester. All right. Well, good night.
Thank
All right,
you.
take care, everyone. Bye.